Ever found yourself pondering why the Pythagorean theorem holds such significance in mathematics? This theorem, attributed to the ancient Greek mathematician Pythagoras, is a cornerstone of geometry. It's a simple equation, yet its universal applicability is astounding. From architecture to space travel, this theorem shapes our understanding of spatial relationships. It's not just an abstract concept, but a foundational tool for mathematics, helping us to navigate the complexities of our three-dimensional world. Stay tuned as we delve into the nuts and bolts of this fundamental theorem. The Pythagorean theorem didn't just pop out of nowhere. Born in the cradle of the ancient Greek civilization, it was named after its reputed father, Pythagoras. This celebrated philosopher and mathematician was a man of many talents, but it's his theorem that has etched his name into the annals of history. Now picture the 6th century BC. Greece was a bubbling cauldron of intellectual curiosity, a place where philosophy, science, and mathematics intertwined. It was in this vibrant milieu that the Pythagorean theorem was conceived. Pythagoras, captivated by the beauty of numbers, noticed a particular relationship between the sides of a right-angled triangle. He discovered that the square of the longest side, or the hypotenuse, was equal to the sum of the squares of the other two sides. This revelation was monumental, a breakthrough in geometric understanding. Now that we know where it came from, what exactly is this theorem? Stripped down to its core, the Pythagorean theorem is a simple yet powerful equation. Let's start by looking at the equation itself. A squared plus b squared equals c squared. It's quite a mouthful when we say it like that, isn't it? But don't worry, we'll break it down piece by piece. First, let's talk about what these a, b, and c represent. In the context of the Pythagorean theorem, these letters stand for the lengths of the sides of a right-angled triangle. A and B are the lengths of the two shorter sides, also known as the legs of the triangle. C is the length of the longest side, which we call the hypotenuse. Now let's talk about what squared means. When we say a squared or b squared, we're talking about multiplying the length of that side by itself. So if a was 4, a squared would be 4 times 4, which equals 16. The same goes for b squared. Now, the heart of the theorem, the equals sign. This tells us that if you add up a squared and b squared, you will get c squared. In other words, the sum of the squares of the lengths of the two shorter sides of a right-angled triangle is equal to the square of the length of the hypotenuse. It's like a magical mathematical recipe. Take two squares, add them together, and voila, you've got a third square. That's the beauty of Pythagoras. It's a wonderfully simple equation that holds a profound truth about the geometry of our world. And that's the Pythagorean theorem in a nutshell. It's a cornerstone of geometry, a key piece of the mathematical puzzle that helps us understand the shapes and spaces around us. It's a fantastic tool for anyone who needs to calculate distances or angles, whether they're architects designing buildings or astronauts navigating the cosmos. With the equation dissected, how does this theorem work in practice? Understanding the Pythagorean theorem is best done through examples, so let's get right into it. Picture a right-angled triangle, any triangle, as long as it has that 90-degree angle. The sides that form this right angle are known as the legs, and the longest side, opposite the right angle, is called the hypotenuse. Now let's say one leg is 4 units long, and the other is 3 units long. The question is, how long is the hypotenuse? The Pythagorean theorem tells us that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So, we square the lengths of the legs, 4 and 3, which gives us 16 and 9, respectively. Adding these together, we get 25. The square root of 25 is 5, so the hypotenuse of this triangle is 5 units long. Let's take another example, a bit trickier this time. Suppose we have a right-angled triangle with a hypotenuse of 10 units and one leg of 8 units. The length of the remaining leg is what we're after. Again, we use the Pythagorean theorem. We square the length of the known leg and the hypotenuse, which gives us 64 and 100 respectively. According to the theorem, the square of the unknown leg equals the square of the hypotenuse minus the square of the known leg. So, 100 minus 64 equals 36. The square root of 36 is 6, so the unknown leg is 6 units long. These examples illustrate how the Pythagorean theorem allows us to find the lengths of sides in a right-angled triangle, provided we know the lengths of the other two. It's a simple concept, but it's a powerful tool in geometry, and it's not just confined to the classroom. Examples help illustrate the theorem, but where else does it come into play? The Pythagorean theorem isn't confined to the classroom. It's at work in the world around us. Take a moment to consider the buildings around you. They're not just slabs of concrete and steel. They're geometrical masterpieces, and the Pythagorean theorem is part of their DNA. In construction, this theorem is used to ensure the integrity of structures. For instance, builders use it to verify right angles, ensuring walls are perpendicular to the ground and corners are true right angles. Without Pythagoras, our buildings might not be as sturdy or as safe. Now, let's delve into the world of technology, specifically Global Positioning System, or GPS. Have you ever wondered how your phone knows exactly where you are, or how to get to your chosen destination? That's right, the Pythagorean theorem is at work here too. By measuring the distance between a GPS satellite and your device, and doing the same for a few more satellites, your device can pinpoint your exact location on Earth. It's a complex web of calculations, but at its heart, it's Pythagoras. Finally, let's jump into the sports arena. In baseball, a player needs to know the quickest way to run from one base to the next. That's a right triangle, with the player's path as the hypotenuse. By using the Pythagorean theorem, the player can calculate the shortest route and get to the base faster. It's not just baseball though. From soccer to basketball, sports are full of right triangles just waiting to be solved with the Pythagorean theorem. As you can see, this theorem is more than just a mathematical concept. It's a key that unlocks a deeper understanding of the world around us. It's the silent partner in construction, the unseen guide in GPS, and the hidden coach in sports. It's the Pythagorean theorem, hard at work in the real world, turning abstract ideas into concrete realities. As you can see, this theorem is more than just a mathematical concept. So, why is the Pythagorean theorem so crucial in mathematics? In our journey through the world of Pythagoras, we've discovered that this theorem is far more than a simple mathematical statement. It's a fundamental principle, a cornerstone that holds up the edifice of geometry and, by extension, much of mathematics and physics. Let's take a step back and recap what we've learned. The Pythagorean theorem tells us that, in a right-angled triangle, the square of the length of the hypotenuse, that's the longest side, opposite the right angle, is equal to the sum of the squares of the other two sides. Put simply, if you square the lengths of the two shorter sides and add them together, you'll get the square of the length of the longest side. This theorem is not just a theoretical construct. It has practical applications that permeate our daily lives. From the construction of buildings to the navigation of ships, from the design of sports fields to the calibration of satellite orbits, the Pythagorean theorem is silently at work, ensuring accuracy and precision. We walked through examples to illustrate this theorem in action. We saw how a ladder leaning against a wall forms a right triangle, and how the theorem can help us determine the height the ladder can reach. We learned how architects use the theorem to create right angles in buildings, and how astronomers use it to calculate distances in space. The beauty of the Pythagorean theorem lies in its simplicity and its universality. It applies to any right triangle, no matter the size or the dimensions. It's a truth that holds, whether we're dealing with the microscopic world of atoms or the vast expanses of the universe. And most importantly, the Pythagorean theorem is a testament to the power of human curiosity and intellect. Pythagoras, living in ancient Greece more than 2,000 years ago, sought to understand the world around him, and in doing so, he uncovered a fundamental truth about the universe. This truth has remained unchanged, unchallenged, and as relevant today as it was in Pythagoras' time. So the next time you encounter a right triangle, whether it's in a math problem, a piece of architecture, or a constellation in the night sky, take a moment to appreciate the profound insight it embodies. Next time you see a right triangle, remember, it's more than just three sides. It's a testament to the enduring power of Pythagoras' theorem.